Moving on to 8th question. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. Now moving on to solution. Here, given that ABCD is a quadrilateral and it is circumscribed by a circle which intersected the quadrilateral at points PQRS. If we consider the points separately A, B, C and D, then AS, AP or tangents from point A, PB, BQ or tangents from point B to the circle, and CR and CQ or tangents from the common point C to the circle, and DS and DR are the other two tangents from point D to the circle. We know that lengths of tangents from common point to the circle are equal. Let us initially consider the tangents from point A, that is AS will be equal to AP, comma. If we consider from point B, the tangents are BP and BQ, those lengths will be also equal. And from point C, CR and CQ are tangents, those lengths will be equal. And from D, DS and DQ are tangents, those lengths will be equal. Now initially, let us add the equation number 1, that is AS is equal to AP, and the fourth equation, that is DS is equal to DR. Then we get AS plus DS is equal to AP plus DR, which implies AS plus DS is nothing but, from the figure we get AD. Therefore AD is equal to AP plus DR. Let it be as equation number 1. Now let us also add the second and third equation. Then we get BP plus CR is equal to BQ plus CQ. That implies on the right hand side, if we consider BQ plus CQ is equal to BC, which is equal to BP plus CR. Let it be as equation number 2. Then we get, let us add equation number 1 and 2. Then we get AD plus BC is equal to AP plus DR plus BP plus CR, which is equal to, let us write AP plus BP together and DR plus CR together, which is equal to AP plus BP. Here from the figure we get it as AB, and DR plus CR from the figure we get it as CD. Therefore finally we get AD plus BC is equal to AB plus CD. Moving on to 9th question. In figure 10.13, XY and X dash Y dash are two parallel tangents to the circle with center O and another tangent AB with point of contact C intersecting XY at A and X dash Y dash at B. Prove that angle AOB is equal to 90 degrees. Now moving on to solution. Here he has given that XY is parallel to X dash Y dash. In between a circle is present with center O, and he also says that a tangent is drawn through point C intersecting XY at A and X dash Y dash at B. And finally he asks us to prove that angle AOB is equal to 90 degrees. In order to prove this, let us initially join OC. Now let us consider the two triangles, that is triangle AOP and triangle COA. In these two triangles, angle OPA is equal to angle OCA, that will be equal to 90 degrees, since at the point of contact the tangent and the radius will subtend an angle of 90 degrees, and here in both the triangles we have OA as the common side. Therefore OA will be equal to OA, which is common side in both the triangles, and also OP will be equal to OC, since it is the radius of circle. All the radius from the center to the any point on the circle will be equal. Now hereby side, angle, side property of congruency, we can say that triangle OPA is congruent to triangle OCA. That is by S.A.S property of congruency, we can say angle. Therefore by S.A.S property of congruency we can say triangle OPA is congruent to triangle OCA. We know that when two triangles are congruent, then their corresponding angles and corresponding sides will be equal. That is, here we can equate angle POA in triangle OPA and angle AOC in triangle OAC will be equal. That is, angle POA is equal to angle AOC. Let it be as equation number 1. Now again, let us consider the two triangles, that is triangle OCB and triangle OBQ. Now in triangles, triangle OBC and triangle OBQ, angle OQB will be equal to angle OCB, that will be equal to 90 degrees, since at the point of contact the tangent subtends an angle of 90 degrees with the radius from the center, and also in these both triangles we have common side as OB, that is OB is equal to OB, which is common side for both the triangles, and also OQ will be equal to OC, since it is the radius of the circle. Now here again by S.A.S property of congruency, we can say triangle OBC is congruent to triangle OBQ. When two triangles are congruent, then their corresponding angles and corresponding sides will be equal. Therefore here we can equate angle QOB and angle BOC, that is angle QOB is equal to angle BOC. Let it be as equation number 2. Now if we consider PQ as line segment and O as a point and OC as a ray intersecting PQ at O, then angle POC and angle COQ form a linear pair here. Therefore we know sum of angles that form a linear pair is equal to 180 degrees. We can say here we can say that angle POC plus angle COQ is equal to 180 degrees, which implies here we got in the first equation that we can write angle POC as sum of angles POA and AOC, that is angle POC can be written as angle POA plus angle AOC plus again angle COQ can be written as angle COB plus angle BOQ, which is equal to 180 degrees. That implies here in the first equation we got angle POA is equal to angle AOC. So let us substitute that. That is angle AOC plus angle AOC plus let angle COB remain as it is plus angle BOQ or angle QOB, we got it as angle BOC in the equation number 2, which can also be written as angle COB, that is equal to 180 degrees, which implies angle AOC plus angle AOC is nothing but 2 times AOC, and angle COB plus angle COB is nothing but 2 times COB. Therefore, we get the equation as 2 times AOC plus 2 times COB is equal to 180 degrees. Let us take 2 common here. Then we get angle AOC plus angle COB is equal to 180 degrees. That implies angle AOC plus angle COB is equal to 180 by 2, which is nothing but 90 degrees. That implies finally we got that angle AOC plus angle COB is equal to 90 degrees. Let us check in the figure. This sum is equal to the which angle? So now moving on to the figure, we see angle AOC plus angle COB is nothing but the whole angle AOB. Therefore, here we get angle AOB is equal to 90 degrees. This is what the required proof for us. Moving on to 10th question, prove that angle between the two tangents drawn from the external point to the circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. Now moving on to solution. Let us consider a circle with the tangents drawn and having the center O. Let us draw a circle with center O and tangents AB and AC are drawn from point A to the circle. Now he asks us to prove that angle between the two tangents drawn from the external point, that is angle BAC, and is supplementary to the angle subtended by the line segment joining the points of contact at the center. Here B and C are point of contact. So OB and OC are the lines joining point of contact to the center. He says that angle between tangents, that is angle BAC, is supplementary to angle BOC. That means we need to prove that angle BAC plus angle BOC is equal to 180 degrees. Now we know that in a circle, if a tangents are drawn from external point, each tangent will be perpendicular to the line joining center and the point of contact of the tangent. Therefore here angle ACO is equal to 90 degrees and also angle ABO will be equal to 90 degrees. Now if we observe the figure clearly, here ABOC formed is a quadrilateral. We know sum of angles in a quadrilateral is equal to, we can say here, angle BAC plus angle ABO plus angle BOC plus angle OCA is equal to 360 degrees. That implies angle BAC, let it be as it is, plus angle ABO, which is nothing but 90 degrees, plus angle BOC, let it be as it is, plus angle OCA, which is also nothing but ACO, that is 90 degrees, is equal to 360 degrees. That implies angle BAC plus angle BOC plus 90 plus 90 is nothing but 180 degrees is equal to 360 degrees. That implies angle BAC plus angle BOC is equal to 360 degrees minus 180 degrees, that is nothing but 180 degrees. Therefore, angle between the two tangents is supplementary to the angle subtended by the line segment joining point of contact at the center. This is what the required proof for us. Moving on to 11th question. Prove that parallelogram circumscribing circle is a rhombus. Now moving on to solution. Let us consider a parallelogram PQRS circumscribing a circle as shown in figure. And here the circle is intersecting the parallelogram at 4 points, that is A, B, C, D respectively. Now let us note down the information that PQRS is a parallelogram circumscribing the circle and circle intersecting the parallelogram at the points A, B, C, D. Now, let us note on the properties of parallelogram, that is, opposite sides are parallel and are equal. Therefore, we get PQ is equal to SR and PS is equal to QR. Now, if we consider from point S, SA and SD are tangents to the circle. Therefore, the lengths of the tangents from an external point to the circle are always of equal length. Therefore, AS will be equal to SD. Similarly, if we consider the other points, that is P, Q and R, the lengths of tangents from P, Q and R respectively to the circle will be of equal lengths, that is PA will be equal to PB, that is tangents from the point P, and QB will be equal to QC, tangents to the circle from point Q, and RC is equal to RD, that is tangents to the circle from point R. So now, let us add the first two equations, then we get AS plus PA is equal to SD plus PB, which implies from the figure we get AS plus AP is equal to PS, which is equal to SD plus PB. Let it be as it is. Name it as equation number 1. Then let us add the other two equations, that is QB plus RD is equal to QC plus RC, which implies QB plus RD, let it remain as it is, which is equal to QC plus RC, here is nothing but QR. Let us name it as equation number 2. Now, let us add both the equations, then we get PS plus QR is equal to SD plus QB plus PB plus RD, that is equal to, here SD plus RD is equal to RS and QB plus PB is equal to PQ. So we get the solution as PQ plus RS. That implies PS plus QR is equal to PQ plus RS. That implies as PQ is equal to SR and PS is equal to QR, let us substitute them. 2 times PS plus QR, let us replace it by PS, is equal to PQ, let it be replaced by SR, SR plus SR. That implies 2 times PS is equal to 2 times SR, that is nothing but PS is equal to SR. As PS is equal to SR, we can say PQ is equal to SR is equal to PS is equal to QR. Therefore, now in parallelogram PQRS, the adjacent sides are equal. Therefore, PQRS is a rhombus. Finally, we can say that a parallelogram circumscribing circle is nothing but rhombus.